Hello. All right, let's graph some stuff. Sounds exciting, right? All right. So we are doing a system of inequalities. We need to graph the solution set, which is just graph them. We're going to find the coordinates of the vertices, which is just where all the lines intersect. And we're going to state whether that solution set is bounded by the lines or not bounded by the lines. Okay, let's just dive right in. So if you've got vertical horizontal lines, I think that's a good starting place. Those are easy to do. Pay attention to whether it will equal or not equal. That's going to change the nature of the line. So the not equal to, it'll be a dashed line, and the equal to will be a solid line. I've shaded it in a little bit like that, so we know that the x equals -3 is going to be on the right side. In class, when I'm doing this on paper, I might just draw an arrow to the right rather than full on shading. And then less than y equals 2, that's got the dashed line. And so I might draw an arrow going down from that line to indicate that. So there's kind of a lower right region that we're going to focus on where the origin is, like that. We have two values, x and y, so we know the intersection, that's going to be a vertices, possibly a vertices, we'll see. And because that line is dashed, that'll be an open dot. Like that. All right, so let's go into the diagonal line like that. And I'm just going to find x and y intercepts and plot them and connect the dots as I like. If you want to do it differently, that's fine. Just graph a line. It's you know how to do that. So I got my x and y intercepts, and I put that down there. And now I can see this has created a triangular region where all three of the lines intersect. And I know that we're only focused on at the bottom. Remember, below the dashed line, so I know that triangular region is not going to be the solution set. That would be the bounded solution set. And then that intersection at the top of the triangle would be a vertices, but not in this case because I'm looking below the dashed line. So I need to know whether it's going to be on which side of the diagonal line. So now that I'm just focused down there, I can look on kind of the left of the diagonal line, the origin is there, or the right of the diagonal line, and I can use a value on the x-axis to make y equals 0. So we've got I think I said all that stuff like that. So the other vertex, I didn't mark it on the graph. I know that the horizontal line is 2, so I plug it in, solve for x, and I've got that point. All right, so I'm just going to test the two regions. Like I said, left of the diagonal is where the origin is, and then right of the diagonal, I can do something else like that. And when you test that point, make sure to test all three of the equations, or however many equations there are, on the off chance maybe we did something wrong elsewhere. But the origin 0, 0 satisfies all three of the inequalities, and so I know that's where I'm going to shade things like that. All right, so below the dashed line, the diagonal line should be dashed as well. There's the other vertices. Like I said, the vertices at the top of that triangle is not for the solution set. And because there is nothing down at the bottom, it just keeps going to infinity, negative infinity, and out to the right, positive infinity, I guess, like that. So it's not bounded. The solution set is not bounded. Awesome.